This part of a talk, we're going to be talking about Nash equilibrium. Now, in our last video, we talked about how a firm or a player could have a dominant strategy. In other words, you will do the same thing no matter what your rival does. Now, that does not require a lot of strategic thinking when you have a dominant strategy. But what happens if you don't have a dominant strategy? Is there a way for you to predict the outcome of a game when no player has a dominant strategy? And that's where the Nash equilibrium comes into play. When no dominant strategy exists, the best strategy depends on the strategy of your rival. So in other words, given what your rival is doing, what should you do? Should you continue what you're doing, or should you switch your strategy? And basically, you are in a state of equilibrium, a Nash equilibrium, where you cannot make yourself better off given what your rival is doing. So let's look at an example. You and I are in a game, and I look at what you're doing, and I ask myself a question. Can I make myself better off switching to a new strategy? If I cannot make myself better off, we are in a Nash equilibrium. Now, this is, of course, assuming that you're in the same situation. You can't make yourself better off given what I'm doing. Now, if you are doing something and I find out that I can switch my strategy and make myself better off, we're not in a Nash equilibrium. And when you think about it, the word equilibrium is a state in which there is no pressure to change. If it is in my best interest to change, then we're not in equilibrium. Let's look at an example. So here's the example. Oh, wait, I'm sorry, my PowerPoint has just kind of messed up here. Let me get to this point right here. So let's look at a situation where it's going to be a simultaneous move game, so we'll be using normal form. And we've got two managers who want to maximize market share, and their strategies are different pricing strategies. And so it looks like this. Manager 1 can charge 1 of 3 prices. Manager 2 can charge of 1 to 3 places. And we see here market shares. So if Manager 1 charges $10, Manager 2 charges $10, each will get a 50% market share. The first number goes to Manager 1, the second number goes to Manager 2. So in the first video, I told you that there are 3 steps to thinking about game theory in in normal form. Step 1, decide who you are. Step number 2, choose a strategy for your rival. And step number 3, choose your best response to that strategy. Well, we're going to do the same approach. I'm going to show you how to find the Nash equilibrium, and I'm going to use 2 different ways of doing it. One is the hard way, one is the easy way. Now, why am I showing you the hard way? Because the hard way forces you to read the matrix from both players' perspective. The easy way, you can get straight to the Nash. So let's start with the hard way first. So step number 1, choose who you are. You're Manager 1, right? And step number 2, choose a strategy for your rival. So let's say Manager 2 charges $10. Now, let's say you charge $10. You both get 50% market share. Now, is it in your best interest to switch your strategy? So keep Manager 2 at 10. If you go to $5, your market share jumps to 0.8. So you want to switch. So this means you cannot be in Nash. In Nash, there would be no reason for you to switch. So what about if you charge $5? Is there any incentive for you to change? Well, given your rival is charging 10, if you switch to $1, your market share grows. So there is no pressure. There is a reason for you to change, not Nash. What about here? If you charge $1, your rival charges 10, there is no longer any pressure for you to change, because if you went back to $5, your market share would drop from 0.9 to 0.8. And if you go to $10, your market share would drop from 0.9 to 0.5. So there is no pressure for you to change. This is a possible Nash. I say possible because manager 2 has to be in the same situation. So let's look at manager 2's perspective. Manager 2, that's who you are. If manager 1 charges $1, manager 2 is getting a 10% market share. If manager 2 changes their strategy to either $5 or $1, their market share grows, right? So this cannot be a Nash because both players have to be in a situation where there's no pressure to change. So we eliminate that one. So let's go back to being manager number 1. Manager 2 charges $5, you charge $10. You have a 20% market share. If you drop your price from 10 to 5, your market share grows, can't be Nash. What about here? You charge 5. Well, if you drop your price to $1, your market share grows, can't be Nash. Now, this could be a Nash because you do not have any incentive to switch your pricing strategy. The question is manager 2 in the same situation? Well, let's say you're manager 2. Manager 1 charges $1. You charge $5. You have a 20% market share. Is there an incentive for you to switch? Yeah, if you charge $1, you now have a 50% market share. So this can't be Nash. You're back to being manager number 1. You charge 10, manager 2 charges 1. You have a 10% market share. If you switch your strategy to 5, your market share grows. Can't be Nash. What about here? Well, if you switch to $1, your market share grows. Can't be Nash. Here, this is a possible Nash for you because you cannot charge a higher price and get a higher market share. What about manager 2? If manager 2 charges 1, manager 1 charges 1, we see that if manager 1 tries to lower their price or raise their price, they get lower market share. So this is your Nash equilibrium. No player has an incentive to move from this outcome, and this is where you would end up. Now, remember, this was the hard way of determining Nash. Let me show you the easy way. The way the easy way works is your manager to 1. Choose a strategy for your rival. Your rival chooses $10. Now, what you do is you just look at your possible outcomes, and you simply underline the best one. So I underline 0.9 because if I charge $1 when my manager 2 charges $10, I get a 90% market share. So do the same thing. What if manager 2 charges $5? What is manager 1's best option? I look at the possible options and I underline the best one. What if manager 1 charges $1? What are the best options? Now I'm going to do the same thing for manager 2. I'm going to assume manager 1 charges $10. Then I look at what manager 2 can charge and the outcomes. And this is the best outcome. If manager 1 charges $5, I look at what the possible outcomes are, and this is the best outcome. Same thing again. Manager 1 charges $1. What can manager 2 do? Well, the best outcome is 0.5. The square with the 2 underlines is the Nash equilibrium. So this is the easiest way for you to find the Nash equilibrium.